Hello, everyone. Welcome to our virtual architectural seminar series. We have been providing architects with these valuable educational opportunities for over 30 years, and we are pleased to find a safe way to continue to provide this value-added service. I'm Vicki Strand, the Director of Marketing and Communications for Construction Supply Group. We're excited to begin our integration with our Construction Supply Group businesses and Whitecap. We are combining to better serve you. Our mutual commitment to being better together and building trust on every job by providing you with exceptional service, knowledge of the industry, will always be our top priority. If you're joining us for the first time today, welcome. If not, welcome back, and thank you for joining us for session 2. As a reminder, today's presentation is an AIA-approved 1-hour 1 HSW credit event. Today, we will learn about how to eliminate flooring failures with Sinak. Sinak will provide an overview of the considerations when installing concrete to receive floor coverings with guidance on proper specification of concrete mix design, placement, curing to secure a warranted floor covering system for a project. Before we get started, we would like to go over a few items so you know how to participate in today's event. We do have everyone muted as to eliminate any noise and distraction. We've taken a screenshot of the attendee interface. You should see something that looks like this on your own computer desktop in the upper right corner. When you join today's call, you selected to either join by phone or computer audio. If for any reason you would like to change your selection, you can do so by accessing your audio pane in your control panel. You will have the opportunity to submit text questions to today's presenter by typing your questions into the questions pane of the control panel. You may send in your questions at any time. We will be collecting these and addressing them during the Q&A session at the end of today's presentation. I would now like to introduce today's presenter. His name is Jeffrey Mosley of Sinak Corporation. Jeffrey has been in the construction industry for over 38 years. His diverse background as a C-33 contractor, territory manager for BASF, and senior technical representative at Sinak bring a wealth of knowledge to his presentation. This real-world experience is used to educate architects, engineers, contractors, and owners in the prevention of concrete issues. Jeff is the author of The Architect's Guide to Concrete, a member of CSI and voting member of both the ASTM C9 and F6 committees. Thank you, Jeff, for being on board with our presentation today. Are you ready to get started?
Thank you, Vicki. Yes, we can get rolling this morning. As Vicki indicated, she gave me a nice introduction there, but let's talk for real quick on who Sinak is. Sinak is a construction chemicals manufacturer. We specialize in sustainable building materials that are not only economically, environmentally friendly, but easy to apply. And because of this, we ultimately save our customers a great deal of time and money in the construction process. Our team is dedicated to excellent customer service, and we go above and beyond that for our clients. Sinak's products are guaranteed to simplify the project, extend the life of your concrete for decades to come. From its inception, Sinak has really been driven to ensure that our solutions for concrete are only the best. Our ability to innovate and develop unique chemical formulations have resulted in us being the pioneers of new categories and new product performance criteria. All of our products are ultra environmentally friendly with 0 VOCs, so you can be assured that you're going to have a cleaner, better construction site. Our technical staff participates in industry-leading groups such as the ASTM, AIA, and CSI, all in order to provide you the best support possible. And along with that support is our decades of construction knowledge, even above and beyond our own current product line. The purpose of today's presentation, again, is just to provide you that overview of considerations that are really necessary when installing concrete to receive flooring, floor coverings, hot, cold applied roofing, anything that goes on top of concrete. I'm going to spend a little bit of time making sure we go over proper specifications and guidance for that concrete mix, the proper methods for placement to make sure that you get the finish that you need, and proper curing, all in order to ensure that when you're done, the concrete that you've installed is going to be able to accept flooring without resulting in flooring failures. It's my goal as a presenter to really break down barriers and change the way that we think about concrete. I know it seems like a very dull subject at times, but concrete in itself is very fascinating. And we've continued throughout our history of construction to use the same means and methods, but expect a different result. By definition, we know what that is. That's kind of insanity, but I'm going to be challenging the norm today. Please feel free to challenge me in the question and answer period of some of the things that I present, because I'm going to be breaking down and addressing some myths within our industry and addressing an overview or a totality of processes to make sure that you can give the Division 9 flooring contractor the concrete substrate he needs to successfully install his floors. Now, the biggest question that we have at closeout time is, does the customer have a warranty? Warranties are essential for your client. And to ensure that they have a release of liability, to ensure that they're protected from future failures and problems, they want to know that they're protected. And sometimes we have a misunderstanding of what these warranties actually cover. For materials warranties, it's simple. Every product manufacturer in the country provides a material warranty that simply says it's going to be the shape, the size, and the color it was on the picture of the box when you open the box. Not all materials come with materials and labor warranties, and in some cases, that material and labor warranty is only to replace the defective item. Do you have a replacement warranty if there's a problem with flooring? What about coverage for remediation? These are questions that we have to ask early in the construction phase, and we should be asking these questions in the beginnings of Division 3, not waiting until Division 9 to start asking the question, because if you don't have an all-inclusive warranty, what happens when there's a problem? Who's going to be responsible for making sure that you're covered? And we want to understand what happens if there's a rejection. These are the things that we want to address early so that we can ensure the client gets what they need. But in order to do that, we have to go back to the beginning of the construction cycle and start to readdress or reassess how we contemplate, think about, and how we specify concrete to receive flooring. Bear with me a moment. I apparently am having a delay. I apologize if you all can hear me. I'm having some technical difficulties.
I can hear you, Jeff. Are you not able to advance right now?
No, the screen is giving me the circling doom, wheel of doom here.
Oh, yes, I do see that. All right. Sorry about this, guys. Let's just give this one quick second. If not, we have a backup plan, no worries.
I don't want that. Bear with me. Let's try this again. Nope.
All right, give me just a second here, and we can solve this issue rather quickly. Give me just a second here. I'm trying to get your presentation queued up here, and we will get this back and going. Yes, it's the circle of life. Thank you, Scott. That's great.
It is definitely frozen.
Yeah, that's okay. No worries. We will. I've got your warranty slide pulled up here, and let's regroup briefly, and I will get this going. All right. Are you able to see my screen now, Jeff?
I am.
Oh, I think I need to flip-flop my slides here because I have a couple monitors going. So let me make sure that I can get this onto, I think you guys are seeing the presentation version, if I'm not mistaken. I'm going to flip-flop a few things here.
I need to open it in my desktop app. Is that what you're saying?
Vicki, I think we've got it squared away on the other end here.
Oh, you got it figured out? Okay, sorry about that. My
okay.
screens were not cooperating either, so I love when this technology works great. Let's flip-flop Jeff back through as a presenter and see how this works. All right, guys, thank you so much for bearing with us. We do these technology checks ahead of time. The vendors are definitely involved. We had a great technology check earlier, and we're actually online and ready to go typically ahead of time, and everything was working great, but this is technology, so I do appreciate your patience. And Jeff, it looks like are you sharing again? Are we good?
I am sharing again. You should be seeing my warranty slide.
Yes, I sure am. I will work on my end just in case this happens again so we can continue on. Thank you, everybody, for your patience. Jeff, you can go ahead.
So here we all thought 2020 was behind us. Apparently it's not. And if it's going to go wrong, it went wrong. So I apologize, but I think we're good to go. So as I was saying, we need to go back and we need to reinvestigate and start over with an introduction to concrete. I know this sounds a little redundant to go back and say, why do I need to learn about concrete again? Well, no matter how you look at it, concrete has become the #1 building material in the world today. And it doesn't matter how you calculate that, from tonnage to square footage to dollar value, it is the #1 building material in the world. And we are consistently innovating and changing and moving forward. And in doing so, it's important to understand a few things that are critical in our industry, especially when it comes to dealing with concrete for floors. And that is simply this. Believe it or not, words do mean things. And we have this bad habit of using different words and thinking they mean the same things. What I mean by that is, if you look at the concept of curing and drying, they're not the same. As a matter of fact, it's really important to define curing in that it is not something that you can buy in a bucket. Curing is not a product. It is a process. Curing is literally defined as a one-way linear chemical reaction that takes place when you consolidate and you bring together all of the different components that make up concrete. So understanding that curing and drying are different is really, really important, because your engineering groups and your concrete people want concrete to be wet. They want it to be wet as long as possible. And in the flooring side, they're constantly asking for it to be dry. So it's really important that we understand the differences. For curing to take place, for that one-way linear chemical reaction to progress, you need water. It requires moisture. And so you have to have internal moisture of 80% relative humidity or more. You have to have internal temperatures of 50 degrees or more, and you need time. And time is what ends up being a critical factor here. Now, because curing is a one-way linear reaction, it can be as short as a couple of days, and it can be as long as several decades. If you can remember the concept of the fire triangle, this will help you better understand the curing process. They're very, very similar. For a flame to exist, you require fuel, you require heat, and you require oxygen. For curing to exist, it's very similar. You need internal temperatures above 50 degrees. You need fuel. You have to have enough cement in your mix to cause that exothermic reaction that takes place when you mix the water and the cement, and that oxygen or that catalyzing agent that causes it all to work is the water. Lose one of the three sides of the triangle and the curing process stops. Like I said, it can last for days, it can last for decades. In 2015, the Army Corps of Engineers put out a report that the Hoover Dam had finally stopped curing. That's a long time to cure, but it was able to maintain the three legs of the triangle. It's also really important to understand that while it can last as short as 3 days or as long as several decades, once the curing process stops and the drying process begins, you cannot go back and reignite the curing process. So you really only get one chance to do this right. It's like burning the fuse off of a candle. It burns its way down. You can't go and add it back up. Drying, on the other hand, is simply what happens when the water leg of that triangle falls away. It's defined as when the internal relative humidity of the concrete drops below 80%, the curing phase stops and the drying phase begins. Now, it's important to understand that the internal relative humidity can go back up above 80%. That does not mean that the curing process restarts. Also, it's important to note that there is no positive effect that drying has on your concrete. It can have a detrimental effect, but there's no positive effect that drying has. And also, if drying is not controlled, it can lead to damage to the concrete substrate. And these are some of the things that we're going to go over. Now, I should have warned everybody, I should have told Vicki in my bio that I went to college to be a history professor. So this presentation will have some history, and I also have an uncle who was a stand-up comic, so you're probably going to suffer a little bit of humor. But hey, if I didn't add some humor to concrete, I'd lose a lot of people. I find it fascinating. But origins of concrete. Why am I showing you a picture of a scuba diver? Well, again, water is a very important component to concrete. This picture happens to be of a core sample that was taken out of a breakwater near Alexandria. It's over 2,000 years old. And what's fascinating about this is you have concrete that's subjected to a wet environment for 2,000 years. And when we investigated or we started looking into this concrete, its internal structures were so dense and so tight that it was virtually waterproof concrete. It was stronger and more durable than anything that we work with today. But I have to assume that most of you on this presentation today don't build breakwaters. Most people that are looking for their AIA units are architects, you're design professionals, you build buildings. Now, most people should see this building and recognize it. This is the Pantheon in Rome. Why am I showing the Pantheon? Well, the Pantheon has a distinction as being one of the oldest continuously occupied, totally cast in place concrete structures in the world. And what's fascinating by this building, not only its design, not only its function and the uniqueness of the building, but if you Google Earth this and flip to satellite and zoom in, what you'll see on the outside of the Pantheon is quite simply nothing but bare concrete. There's no roof membrane, there's no shingling, there's no tars, there's nothing on the outside of the building to protect it. It's completely waterproof concrete that has stood for almost 2,000 years. So the question then that we have is, how is it possible that the Romans could develop and build all of these structures to last thousands of years, and we have estimated life cycles of our concrete structures in business and in industry no more than 20 or 30 years before we start running into problems? So we've had to come back, we've had to look at what changed. We've had to come through the dark ages. We've lost information. All of the knowledge that was gained over hundreds, if not thousands of years, it disappeared. And we've had to come back in and we've had to reevaluate the process. And when you really think of concrete from that perspective, we've only been working with structural concrete in the United States for about 115, 116 years. Yes, we've had concrete prior to that, but not in cast in place concrete structures. So that makes it a relatively new concept, a relatively new building material, even at 100 years old. So as we've started to relearn this, we started playing with our mixed designs. We've played with adding in fly ashes and secondary and tertiary cements. We've developed admixtures and chemicals that we can work into our designs to help improve them, trying to work our way up to something that's going to give us the best quality possible. Regulations and laws have come into effect over time that have changed our access to materials. Here in California, where I live, I can't even take a pint of xylene out to a job site anymore. I'm regulated and controlled now on how I can develop the chemistry of my products. The EPA has changed our regulations, the process in which we can manufacture and process our cements and our ingredients have changed. And then, of course, speed and technology and chemistry, they all play a role in everything that we've had to do. And all of this is compounded over time. And we get under this pressure scenario now where we take our customer a construction schedule and we give them a line out and we say, look, it's going to take 28 months to build your building. And I've never yet run across a customer that says, hey, you're such a great person, why don't you take 30? They don't want that. They want it faster. And your challenge as a design professional now is to integrate this technology and this speed and this chemistry. And they're trying to give your customer a better building at a faster turnaround time for less money. And that's a challenge. And part of that challenge then results in this last item down here, this unearned knowledge or ignorance in our industry. And I want to pause because I don't want to offend anybody when I talk about this section, but I want to illustrate it and try to help us better understand what I'm talking about. If you ever saw the original movie Jurassic Park, there's a really good scene in that film that kind of highlights what I mean here. The mathematician Malcolm explains to the scientists that the problem with what they're doing is they didn't earn the information that they're working with. They simply took what somebody else had done before them and they ran with it. And they got so busy moving forward, asking if they could do something, they never stopped to ask for if they should do something. And this is something that I run across when I do spec reviews. I can't tell you how often I get a master spec and I can obviously see it's been drastically cut and pasted together. And the problem with that is the person doing the moving and the cutting and the pasting didn't have intimate knowledge of where the information came from. And so we end up losing things in translation. So sometimes it's really important to go back and relearn or re-educate ourselves on what's really going on. Don't always just take for granted that the information you received is accurate and true. Take a moment and go back and make sure you understand where it came from. Now, I did give you a warning of some bad humor. I am going to show disturbing images in the next few slides of a graphic nature, so we want to make sure that some professional discretion is advised in what we do here. And what do I mean by disturbing issues? Well, honestly, remember, we're talking about concrete to receive floor coverings or roofing materials or deck coatings. Now, while everything I talk about is applicable to all concrete, we're going to focus on this. Why is this a disturbing issue? Well, if I have a dusty or friable surface, I can't have anything stick to that. So we need to understand cause and effect. I want to kind of change the way you think about the behavior associated with concrete because it's really fascinating. It has a cause and effect for everything that happens to it. Dusting is simply what happens when too much water is in the mix or too much water comes in contact with the concrete before it's fully set. This can be bad weather related, and sometimes it can even be not enough cement. We run into problems with this all the time in mix design. But either way, I can't stick a floor to this. I'm going to have to reconsolidate. I'm going to have to do extra prep. This is a change order, or this is something that could lead to a flooring failure. We want to learn to prevent these things from taking place. Scaling is another problem we want to pay attention to. Please do not confuse this with a freeze-thaw environment. One of the worst scaling environments in the United States happens to be in Arizona, in the Phoenix market. And why? Well, again, we're trying to speed up the process. We're overworking the surfaces. We're not taking time to wait, and we're worrying about how much moisture is in our concrete, and when we trap it, and we end up with permeable concrete. Now, I touched on permeability earlier when we talked about drying. Here again is another problem. If you have too high a permeability, you can increase the risk of scaling. Again, these are void spaces or spots that your flooring contractor can't cover. And then we get to this nice slide, a disturbing issue. Now, usually when I present this class in person, I usually ask a kind of a joking question, but you know, there are really only two types of concrete that we work with here in the United States, and that's cracked concrete and concrete that's going to crack. And we say it as a joke, but the reality is concrete is designed to crack. Its very nature of what it does says it's going to crack, and so we give it joints, and that's really important. But there are other instances of cracking that we need to learn how to control, because controlling and preventing problems from occurring are much more cost effective than trying to fix them later. Just like curing, once it stops, it can't restart. Once cracking starts, you really can't mend it back together in a aesthetically pleasing way. So crazy. This is a non-structural phenomenon. It really doesn't affect my ability to install a floor properly, and it probably won't contribute to a flooring failure. However, one of the categories of flooring that we don't talk about often is diamond polishing or staining and polishing concrete. And in all my years as a contractor, this is one of those phenomenon that I could never convince my client was an architectural feature I didn't charge them extra to achieve. The reality is this can easily be prevented from happening if we understand the process of that curing and drying. Make sure we don't get the surface drying too quickly. Additionally, we have to deal with rapid moisture loss of a slab. If we don't control the rate at which moisture leaves the concrete, we end up losing tension. That loss of tension is what causes the concrete to shrink, and it's behavioral. If you notice on the slide, this is kind of a little trivia question for you. All of the cracks run the same direction. And the reason for that is concrete is predictable in it will always move along the longitudinal axis of the pour. Another way to think about it is something that we're all familiar with is sidewalks. All of your sidewalks have joints. All of the joints are laterally placed along the longitudinal axis because it moves back and forth along its long run. If we understand that behavior, it helps us design and place concrete properly to avoid these situations. Putting the joints in right and controlling the loss of moisture will prevent cracking from taking place, both in the curing and in the drying phase, if we understand the behavior. And then we get to the bullseye here. Now, while this looks like or appears to be a crack, the crack is simply a symptom or a result of an underlying problem. And that underlying problem here is curling. Believe it or not, concrete is a very unique three-dimensional dynamic object. It is not a two or one-dimensional static object. What I mean by that is you have to address all 6 sides of a three-dimensional object to ensure stability. And in concrete placement, this is also something we need to do. The reason for the cracking that you see here around these joints is this. The top of the concrete was very smooth and tight. The rate at which the water left the concrete on the surface was slower than the rate at which the concrete left the joints. That caused stress to build up, and the 4 corners of the joint actually started to lift or pull away and rise up, causing curling. Then, as forklift traffic in this warehouse drove over it, eventually the load and the stresses caused it to snap, dropping back into place, resulting in this circular crack or radial crack around the joint. This can be prevented or fully eliminated if you ensure to cure the vertical surfaces of the joint wall the same way you cure the top of the slab and the same way you cure the edges of the slab. Then we move into graphic images. Why are these graphic? This is disturbing because by the time this presents, your owner's taken possession of the building, and then you get the phone call. Is this a moisture problem or an adhesive problem? What about reversion? You know, sealants can actually go from a solid back to a liquid if they're subject to a harsh chemical environment. We need to understand, is this moisture? Is this alkalinity? Is this chemical attack? Efflorescence is another phenomenon that most of us are familiar with. This is, again, moisture vapors or moisture migrating back and forth through concrete will wick out mineral deposits, causing this mineral to grow on the surface, and it's expensive. It can damage your flooring. You can prevent or minimize this from ever occurring by understanding cause and effect. And then finally, we get to probably my most graphic and disturbing photograph here. And for some people, this photo has been around for quite a while, and it's a great time to pause and make some illustrations. I've talked a little bit about behavior of concrete, and so I like to pause at this photo. I usually ask people questions. Where do you think the water is coming from? And I get a lot of the same answers. Well, obviously they didn't put a barrier under the concrete, and that's water coming up from the soil, or water from a high water table is leaching up into the concrete. The other response I get a lot is there's a broken water pipe underneath the slab, or there's a flood that was outside from rains, or landscape that was sloped back towards a building, worked its way under the foundations. The reality is this phenomenon actually took place in a third floor pan deck at a clean room. And so that causes people to pause because, again, I'm changing the way that we think about moisture and concrete and how they relate to one another. Concrete, again, is very fascinating. It will take moisture from wherever it can get it. It will hold on to it, and it will release it at a slower rate than which it obtained it. So in this particular instance, we know we're not touching dirt. We know we don't have any plumbing inside of a pan deck. So where did all the water come from? Well, unfortunately, underneath that pan deck was a laundry room. The laundry room was generating high moisture and steam. It worked its way up through the flutes in the pan deck, and managed to saturate the concrete, eventually coming into contact with the epoxy coating, condensing into a liquid, causing a separation. So again, changing the way we think about our designing helps us prevent these from ever happening again. And this phenomenon can happen on a pan deck, it can happen on a post-tension deck, it can happen on a roof deck. Moisture always finds a way to work its way into concrete. And we want to make sure that we fully treat that concrete to get the best quality possible. So what are some fixes? You know, the industry's recognized these problems. You'll notice some of the photographs were black and whites. This is not a new phenomenon that we've been working with. And as an industry, we've worked to develop a process over time where we started to use poly or plastic underneath the concrete. And when the poly or plastic under the concrete didn't work, then we started to use an improvement. We started putting Stego or Viper or another 15 or 12 mil poly. The ACI has argued for years on where the sand bed goes. Does it go on top of the poly or below the poly? We would love to water cure every job, but we know we can't really effectively do so. So we started to allow blankets and diapers and burlings to be applied. And here's where we are in the spec world today. This is what I see almost on a daily basis. We'll go into Division 3 and we'll specify a concrete flooring system. Then in Division 9, we'll specify an epoxy remediation system to go on my concrete flooring system so I can install a vinyl flooring system. That is the lunacy of the world that we live in today, because we've consistently been doing it the same way over and over again and consistently having problems over and over again. From an internal aspect, we've worked on developing our mix designs. We've added water reducing admixtures. We've added vapor control admixtures. We've worked on water cement ratios. We've worked on different types of cements. You know, there's type 2 and type 5 and type Ks. There's crystalline waterproofings that came out in the late 70s that we've tried to work with. And at the end of the day, due to all of those VOC laws and regulations that I talked about earlier, you're stuck now with only acrylic resins and chemistries that are weaker than they were 20 or 30 years ago. If you're confused about the process, here's some more of my bad humor. My heart's with you. You know, this is the reality of where we are in the industry today and some of the troubles that we've had to deal with. So my question then is, everything that I've showed you prior to now, all of these conditions are actually preventable. Most of the conditions that I've showed you aren't really the cause of flooring failures. We get a misunderstanding. Floors don't fail due to high alkalinity. Floors don't fail due to moisture under the concrete or in the concrete. Floors don't fail due to moisture vapor. Those are all symptoms of an actual underlying cause. It's very much the same as the cracking that I showed you on the curling slide. So what is the reason why floors fail? If you understand the number one reason, the root cause of the problem, it will help you prevent it from ever presenting, and it'll allow you to stop treating the symptoms through remediation and start addressing the disease itself and prevent it from ever presenting. The number one flooring failure cause is permeable concrete. I started with this in the beginning about drying too soon. We talked about it with scaling. It's the permeability of the concrete that is the number one reason why floors fail. If that's true, and it is, it's been proven and over again, then the number one goal in making sure that we can eliminate flooring failures from ever happening is to achieve something called a discontinued capillary matrix. Now, I know this is where I usually lose people, so I want to explain. I joked earlier that there's two kinds of concrete in the world. There really are two kinds of water used in the production of concrete. There's water of convenience for placement, and there's water of necessity for hydration. We know we need the water to be there, but how much? That becomes our question. So what is a capillary matrix? Well, the capillary structure or the capillary matrix is that matrix or that freeway that presents itself when that water of convenience has to go away. We call it bleed water. It comes to the surface, it evaporates off the top, and it leaves behind this freeway, which for those of you who don't know, that's the 405 freeway in Los Angeles on any given day. I recommend you stay away from LA at all costs. But the reality is we want to take this and we want to minimize it. We want to reduce it. We want to shrink it down to something controllable. We want to take the same freeway and we want to shut it down. We want to close it off. We want to stop the means of transportation because, again, if the concrete doesn't have high permeability, none of the symptoms will present and none of the problems that you currently see with flooring will ever happen. And we can do that and we can measure it. And that's the trick, being able to get it down to something less than 3 pounds. You'll never shut it off completely, but you can reduce it to a controllable level. So how are we going to do this? This is really important. We need to understand the process. We've already started that today. We've walked through the process of how the behavior of concrete works. We've looked at some cause and effect so that we can try to address them and prevent them. And prevention really is the most cost-effective means of building. It's much cheaper to do it right than it is to come back and fix it. We all know this. We can do that by minimizing steps. You know, we have a concrete slab and an epoxy remediation and a flooring system. Let's eliminate some of those steps. Let's reduce the cost associated with building, and let's achieve something that really protects our customers with real warranties that address everything. And it can be done. Step one, anytime you're touching dirt, I highly recommend you use an underslab vapor retarder. It's also important to note that I'm calling it a retarder. It is not a barrier. It does not solve the moisture problems in concrete. Think about it. If this was going to solve all your problems with floors, I wouldn't be giving a presentation today. But I highly recommend them for two reasons. They separate the concrete from the dirt, preventing any type of transference of soils contaminations or moisture from the dirt to getting wicked up into the concrete. They also work as a great underslab curing blanket. I said before, concrete is a three-dimensional dynamic thing. You want to cure the bottom just the same as you cure the tops and the sides. This is why you always use this. Also, we want to talk about the water cement ratio. Now, this is the very first step you can do to ensure that reduced permeability in your concrete. This is the very, very beginning of the process. And it's important that we pay attention here in keeping the water cement ratios below a 0.50. And this is not my words for you. I'll give you an example. Several years ago, the Portland Cement Association did a study in conjunction with the ACI, and they wanted to see, is it possible to get low permeable concrete as measured by 5 pounds of moisture vapor drive or less by just water curing? And what they found was a 0.40 water cement ratio, water cured for 3 days, resulted in less than 5 pounds. At a 0.45, it took 7 days. At a 0.50, it took 14 days. Now, as a former contractor, I can attest. I can probably water cure a slab for 3 days. At 7 days, I'm pushing my limits. Now I'm running risk. At 14 days, it becomes cost prohibitive. But look what happens to the curing times that are necessary when you get above a 0.50. At a 0.60, it would take 180 days to cure the slab properly to achieve a slab to receive flooring without the risk of failure. You simply cannot do it. Think of it like pancakes. If you've ever worked or made pancakes, right? You start with powder, you add water. At some point, it gets nice and thick and pancake consistency as a batter. But if you keep adding water, it just turns to a nasty mess. You'll never get a pancake. You'll just get a mess. Concrete works the same way. You can't take water out of concrete once you add it, but you can always add it. So I always recommend a low water cement ratio or trim water to be pulled out. So let's talk about mix design really quick, because these are all cause and effects that we need to talk about. That water is essential. It's the catalyzing agent that begins hydration. Hydration of the cement is what turns it from a powder to a paste, which starts to develop the strength to stick the rock together. It's that rock that provides you the strength for your design. The sand gives you that density so that you have an aggregated mix, so that you minimize the little voids and capillaries and structures in your mix. And then you've got admixtures. There's a lot of chemicals on the market today. We want to verify compatibility and ensure that we're not adding a contaminant. Now, there should be no reason to use a chlorinated admixture in the United States, but there's still some hiding out there, so we always want to make sure we don't get it in our mix. So then we go to the day of placing, right? We understand our process. We've developed a good specification. We want to ensure the highest quality possible. We're using an underslab vapor retarder. If you look at this picture, we're even using epoxy-coated rebar because we want to make sure our concrete lasts as long as possible. But we have a person with a water hose over here spraying water. I no longer have the ability to control my water cement ratio. I don't know what they're doing. I don't know if they're spraying the dirt. I don't know if they're spraying the concrete. I have no idea. Don't add water at the site. It's very critical that we control every step. We spent a lot of time and money developing a spec. Minimize the chances of risk. Here's a couple of ways that we can mess it up during placement. By the way, these are not my phrases. These come straight out of the industry handbook. Scorched earth. If you look at this finish, burnishing a slab is not the only finish possible. As a matter of fact, if I'm doing floors, I want a class 5 finish or a class 5 slab installed with a light to medium steel trowel finish. The tighter you burnish the slab, the smoother you make the slab, the harder it is for the flooring contractor to get his glue to stick. You're increasing risk by overworking the surface, and you don't have to get it burned to get it flat. What is a hot date? Well, I've been on a job site. The weather got cool. The truck was late showing up. It was a Friday afternoon. A guy literally had a date for his wife, and I came out of the trailer and he's throwing cement powder, feeding the chickens to soak up the water so he can get on to start finishing it. I no longer have control of my water cement ratio. I've increased my risk of scaling. I've increased my risk of problems because all he had to do was wait. It's a one-way linear chemical reaction. If you give it time, it will get to where you need to go. Blessing the slab is another problem. You don't want to use water to facilitate finishing. That's a big no-no, and you don't think about it as being a problem, but let me help you. If I start with a 0.45 water cement ratio and I add 2 tablespoons of water during the troweling operation of finishing, I can increase that surface pace to a 0.8. That gives me a hot spot where any flooring that goes down over that blessed section is going to fail. And then finally, we have acts of God. You always want to make sure that you calculate extra time. Don't pour concrete on a Friday, pour it on a Thursday, just in case something happens. Finishing. Finishing does not mean you're finished. I'd like to say this is the end of the step, but it's not. There's a science to this. Again, heat, wind, weather, humidity all play a role in how that curing process progresses. We need to understand that finishing is providing a texture. The ACI gives you 9 classes of floor that you can install with 9 different finishes. Make sure you get the finish you need for flooring. And then now we get to our last step, curing. This is the proper way to prevent the problem from presenting. It's a process. We know that it's a chemical reaction. We have to control moisture and temperature. This last step is probably the most important thing that you can do to ensure that you're going to get what you need. As a matter of fact, the ACI 302 gives you this quote. It's the single most important factor in achieving a high quality slab. It is as important as water cement ratio in your mix design. And if you don't do this right, it's going to be your worst nightmare. Think about it. That's what we need to deal with. So what's changed, right? I said about 114 years of construction. I'm not going to go into detail, but take note of dates. 1907, we started the process. 1995 was the last time the ASTM presented a new specification for concrete. We're dealing with outdated information and we're dealing with old ways of doing construction. We've gone from building concrete and laying foundations like this to building construction like this, and we haven't paid attention to the methods. So let's understand tests really quickly. This is really important. The ASTM has test methods, specifications, and recommendations. Everything that you see in front of you is probably in your current Division III spec, but it's important to understand some differences here. ASTM C156 is a test method. ASTM C309 and 1315 are specifications. So what's the difference? Well, there's a huge difference. A specification does not have the same weight as a test method. As a matter of fact, if you understand this process, it'll help you. ASTM C309 is a specification for the lowest, barest minimum protection that you can hope to get on a job. This is slightly better than doing nothing at all. In a lot of my specifications that I review, I see people specifying a water cure. There is a water curing performance spec. It's based around the C39 and the 1202. There's also a hierarchy within ASTM. If you specify the minimum standard and somebody submits a higher standard, you should, by rule, accept it. So a lot of times I see specs where you specify a 309, somebody submits a 1315 and it gets rejected because you say, I don't want the extra. You should never reject a higher quality product. And that's important to understand. Also, if you do the job right the first time, if you prevent everything from coming along, you should not need to do any other moisture testing. However, the industry does require or ask that moisture testing be done before flooring is installed. It's important that you do both tests. A lot of people out in the world today say, oh, I only need to use a humidity probe. I disagree. I think you need to make sure both tests if you don't have a system in place that guarantees protection. I can go over more detail on testings and the difference in the Q&A time. So let's talk about the curing methods. The best curing method in the world is water cure or water cure equivalency. If you can get all the benefits of a water cure, I highly recommend that you do so. The pros of water curing are very simple. You're going to have low permeable concrete. I demonstrated that with the PCA slide that showed you the differences. There's no film or residue. It's compatible with all coatings. It reduces cracking during the curing state. Let me rephrase that or reiterate that. It only protects you during the curing state. Water curing does maintain high humidity in the slab so that you can get the tensile strength development you want. However, there are some risks associated with water curing. It can become very labor intensive. It can be very time consuming. On a fast track project, I may not have 7 to 14 days to stare at my concrete and do nothing. To do it correctly, you need a lot of water. That water is going to present a runoff. It could present a hazard. You have risk of premature drying. Think about it this way. If you look at the bottom picture on this slide deck, how did I cure my edges? How did I cure the underside? We don't know. It's not addressing all 6 sides. And if I'm doing polished concrete and I have blankets like the picture on the screen, every one of those wrinkles is going to give me a zebra stripe that I will not be able to grind out. You know, it's just something that we have to be aware of. We have to be able to prevent this. And again, water is only good as long as it's present. When the water leaves, you have no means of controlling the drying phase of concrete. So while water is good for curing, it doesn't protect you during the drying phase. Let's talk about membrane cures, C309s. What are the pros? It's cheap. Remember, 309 is the minimum possible standard ever. It's slightly better than doing nothing at all. It's a hope and a prayer that you might get some protection, that you might buy yourself a little bit of time to at least get about a 3-day cure out of your slab before the resins break down. One of the things I should have commented on my ASTM warning site, ASTM's 309 and 1315 are specifications that are designed around controlling a single element of concrete curing, and that's moisture loss. So the test method, C156, only measures the rate at which water or moisture leaves the concrete, and it sets the minimum standard or the maximum loss rate of 0.55 kilograms per meter squared. 1315 is a 0.40. Anything below a 0.40 is an improvement. Now, I said it only measures moisture loss. Remember our VOC laws? Remember our EPA regulations? You can't use the same resins today that you did in 1956 when these tests were developed. And what that means is, if you look at this picture, all the black dots that you see in the pink field are separations. That's the sodium hydroxide burning the acrylic resin, causing it to separate. So you do not have a monolithic film. You do not have universal protection. You will have highly permeable concrete because you're not getting the protection that you think you're getting, because the test method has never verified chemical compatibility. So new, what is new out there? As of 2018, SpecLink recognized a new curing agent category. Master Spec added it last year in June. The concept or the phraseology for a curing agent has been around for about 8 or 9 years. The products themselves have been around for over 30 years. But curing agent or curing and sealing agent, water cure equivalent type, is the new standard. These are chemicals that replicate a water cure the day of placement, but don't require excessive amounts of water, poly, or plastics. Pros: there is the curing and sealing category that does provide moisture control for your concrete. You can get up to a 20-year labor and materials warranty and even a bond warranty from some manufacturers. They're compatible with flooring and roofing. They've been tested to the highest standards possible under ASTM. They're permanent and they're penetrating agents. So there's nothing on the surface to interfere with anything that comes after them. They're same day access, same day slab placement, and curing all happen at the same time. You can get up to a 28-day water cure equivalency. There's currently 3 standards for the curing agent category. There's a 7-day equal, a 14, and a 28. So you can write a performance spec around these products and ensure diversity. Most can be shot blasted or abraded so that you don't void your warranty, and they're all zero VOC products. Cons. Very few manufacturers have been able to meet the highest standard. There are a lot of 7 days out there. There's a few 14 days and 1 or 2 28s. So it's important that you understand and you get involved with the manufacturer's reps or their technical team to write the spec properly. Also, there's still some confusion out there. Believe it or not, there are some people that will propagate misinformation to sell product. Please don't confuse this new category with other products on the market that have similar chemistries. And let me give you an example. If I say the word urethane, urethane does not mean it's a bad product. Urethane is an ingredient. A urethane caulking is not the same as a urethane deck membrane. You don't cross-contaminate. Don't allow misinformation to rule the day. Here is an example. University of Texas in Austin was conducting a Department of Transportation study of curing agents against water cure. The lighter color samples were cured in a water closet for 28 days and left in the lab for 2 days to dry. The darker samples were cured with a curing and sealing agent, vapor control, the day of placement, taken outside, left in the environment for 30 days and brought in, and that's the visual difference. Much stronger, much denser, much richer, higher quality concrete. Same batches, 2 absolutely different results. So here's how we're going to eliminate failures. Always use a high quality underslab membrane anytime you're touching dirt. This is essential to protect you from any soils contamination, and it provides you an underslab curing blanket for your concrete. Always specify water cement ratios below a 0.50. I recommend a 4.2 to a 4.5. That ensures you a cushion against human error, because unbelievably, you'll never understand it, but for some reason, the concrete cement truck driver has a tank of water on his truck and he might juice your load. Always compensate for human error. Use your water reducing admixtures. There's lots of things on the market today that can help you improve the quality of your concrete for a lot less money. Take care in finishing. Make sure we know what class of floor you want to receive flooring. Don't add water at the job site. Don't use water for finishing. Use a proven water curing alternative. They're tried, they're true, and they're tested, and they come with some of the best guarantees and warranties in the industry to protect the client. And they do so by dealing with both the curing and the drying phase. And maintain some solid communication start to finish. If you allow Division 9 to at least communicate to Division 3 on what class floor and finish they need, you'll be able to ensure a rapid installation of your floors and make sure that you don't end up with a failure. This now concludes the actual AIA portion of the presentation. I open it back up to Vicki and the team for any questions or verifications or clarifications you might need.
Great, Jeff. Thank you so much. Great presentation, lots of information today. As Jeff said, we are going to answer questions that were submitted through the questions pane. As a reminder, you can still continue to submit your questions as they come up, and we will get started. We are ready to tackle a couple of these. Vapor barriers or vapor retarders trap water at the bottom of the slab, causing different curing conditions at the top and the bottom of the slab. You stated this vapor protection is necessary under the slab. What are your thoughts about having sand or semi-clean compacted aggregate layer above the vapor protection? The slab is then poured on the aggregate layer, not on the vapor protection. What are your thoughts on this? And then there is a follow-up question. Would you like me to read that? It was from the same individual. Follow-up to the previous question, floors that will be in an office that will receive vinyl tile has shown the mastic to fail due to the moisture in the slab. Air-conditioned spaces also see issues with floor surface applications. Suggestions to avoid this issue. What about eliminating vapor protection under the slab in office areas?
Both of those are really good questions and very common. The ACI 302-1R15 put out a really good flow chart to help design professionals put the under slab retarders in the right place. It is kind of on a sliding scale, so there's not a definitive answer, but I will give you the best practices version that I have seen in my 30 plus years of doing this. If you're going to be dealing with flooring on top of your concrete, you always pour the concrete directly on the plastic or the poly. If you use a blotter layer, a sand layer, to take some of the moisture out, it stays trapped. The other problem is concrete cracks, and we know it's going to crack because we put saw cuts. Anytime weather conditions, cleaning on the job site, or additional water is applied to the top of the concrete, it will go down the joints, it will pool underneath the concrete in that blotting layer, increasing the amount of moisture now that you have trapped under the concrete. And because it can only go up, it's going to come back up through the joints and back up through the concrete if the concrete is permeable. Now, if you're pouring directly on the membrane, you must stay below a 0.50, and I recommend a 4.2 to a 4.5 because that's less water that's going to be in contact with the membrane, and you're decreasing permeability. In conjunction, you're looking at this as a building envelope process. So you're dealing with the bottom of the envelope, the middle of the envelope, and the top of the envelope. If the bottom of the envelope has a membrane that allows no moisture to escape, the top of the envelope needs to have a membrane that reduces it to a regulated rate of less than 5 pounds. That would be where I would recommend using one of Sinak's materials or a similar product that is a penetrating vapor control cure or seal that locks everything in and reduces the rate. Now, that will address the concrete slab. On the flip side, the phenomenon of flooring failure over concrete due to air conditioning is because air conditioning units have a tendency to act as dehumidifiers. They actually draw moisture out of the air and condense it on the coils, and that's why we have a drainage system. Because of that, liquid or moisture, whether it is in a solid, liquid, or gas form, always seeks equilibrium. It's kind of a chemistry equation. So if I have a high relative humidity environment in one spot and a low relative humidity environment next to or above the moist environment, the moisture wants to travel up and balance the dry. So it's always looking for equilibrium. By reducing the channels or the venues or the avenues for the moisture to move out of the concrete, you can prevent it from condensing at the bond line. So that's really important to go that route. It's not a single product result, it's a systems approach and understanding. Even on large industrial projects I've worked on, I've encouraged manufacturers to even throw down a 6 mil poly on a warehouse where you normally wouldn't do that. And the reason I do that is, like I said before, we want to control the moisture migration from the soil and the contaminants, but we also want to cure it right. So if you can specify the right cure, and this is really important when we're specifying. We write a Division 3 spec and we want a water cure for polished concrete or diamond polishing sections. And then we want a moisture sensitive flooring that's going to go down. So we want to be able to put either a water cure or a controlling product that's going to control the moisture migration. And then we have outside curb and gutter work that's going to take a 309. The worst word in the English language that I wish did not exist is the 2-letter word or. If you allow the word or to be in your master spec, then the subcontractor will choose the cheapest possible method to apply to all concrete. So I usually specify a vapor control system where it's necessary for flooring, and an exterior and an interior. Breaking out by application is really important to give your contractor the right guidance to eliminate the risk. So for me, to reiterate, I always pour on the plastic. I always cure with a water curing equivalent product, and I always ensure I control the rate of drying. Those 3 steps ensure that when my flooring does come in, it can be installed properly without risk of failure.
All right, great. Let's see here. Do you recommend the cure? Hold on just a second. Let me make sure I'm on the right question here. Sorry about that. Do you recommend cure and sealing products? Are they both the same or typically a combined product? What products for such a treatment does Sinak provide?
So great question. I want to clarify a definition. A curing product is designed to maintain moisture for a minimum of 3 days, possibly 7 before they start to break down. Those are your membranes, your 309s, your acrylics, even some of your dissipating cures. They start to degrade due to atmospheric conditions rather quickly. That means they're only holding moisture for a short period of time. A curing seal product, which would be your ASTM 1315 category, are membrane products that are designed to both cure and seal the product for up to 30 days. That gets you past your initial curing stage, and it starts to degrade as the drying phase starts to come into play. These are not permanent sealers. I've run into lots of instances on projects where I've got riser rooms or utility sections or even small warehouses where the owner gets upset because the concrete starts to dust, and they said, but I used a cure and seal. You have to understand that the word sealer has a broad range of definition. So that's the first thing. The second thing, all Sinak curing products are developed based on function. There's an exterior product for curing called Lithium Cure 1000. That is designed for exterior colored concrete and air entrained concrete. Lithium Cure 2000 is designed for interior hard burnished steel trowel finishes. VC5 is our vapor control line that comes with a 20-year warranty, and WCE is our potable water line for like water treatment facilities. Each of those are permanent. They are applied the day of application. They permanently impregnate the concrete with a lithium quartz matrix that is inorganic, non-soluble, will not degrade, will not wear off, will not go away. So it both extends the curing curve well beyond 30 days, but it also controls the rate of drying permanently so that you get the best results. So it would depend on function. If I'm doing moisture sensitive flooring or I'm doing office spaces, hospitals, or schools, it would be VC5. And that would replace all of your curing and sealing methods and replace any mitigation or remediation in Division 7 or 9 with a single product in Division 3. VC5 does come with a full 20-year non-prorated warranty that covers all 3 categories, moisture, moisture vapor, and alkalinity. It also has the only of its kind in the industry adhesive bond warranty that states properly installing the adhesive, it will bond to the VC5. That makes it extremely unique in the industry. The other aspect of VC5 is the warranty coverage begins the date of installation. The term of the 20 years begins at date of substantial completion. I know it sounds like I'm splitting hairs, but this is extremely important for the general contractors. You are covered the day you apply the VC5. I had a project in Ohio this last year. The architect informed me that because of COVID, there was a delay in turning over the building to the owner. There was a lot of construction delays, but the flooring had been installed, and the floor started to fail before the owner took over ownership. That particular remediation manufacturer had issued the warranty to the owner, but because the owner didn't own the building yet, the general was not covered and had to pay out of pocket to fix the floors. Now, I know that's a rare one-off, but that's the kind of crazy stuff that happens out there in this world, and we want to ensure that we protect against that.
All right. Got a couple questions as it relates to this. If this is a new category, how do I submit it against what's currently specified, and where would I add this to my specification?
Oh, that's a great one. So because ASTM has a hierarchy of acceptance by equal or better than, I would do a submittal package referencing the existing specification section and subsection, and then I would note the performance criteria of the spec. Now, here's what I mean. If a 309 product is specified, that is using an ASTM specification that has a performance criteria of 0.55 kilograms per meter squared. That is under ASTM C156. The intent of this specification is to control moisture loss, not make a shiny acrylic resin sit on the surface. So you would submit a performance-based substitution request. If I'm specifying this new category of curing agent, I would put it in Division 3 because it is a curing agent that's applied at the time of concrete placement. But when I do my master spec reviews, I also include it in Division 9 because Division 9 has the requirements for moisture for flooring. That way you get 9 and 3 talking to one another at pre-construction so that you avoid finger pointing and delays and arguing later in the process. It's much more cost effective to address it early than to try to figure out who's responsible later. This also prevents you from tapping into contingency money that you get to take home if you're a general if you don't use it.
All right. I've got a couple more questions here, and then we'll get wrapped up. So we'll try to get through them as quickly as we can, Jeff. Regarding six-side curing approach, other than measures to the top and the bottom of the slab, how about the four-side?
So as soon as you strip forms, you should always spray the outside edges. As soon as you're done saw cutting, you should spray the saw joints. Now here's the problem. If you're using a membrane, a 309 or a 1315, those are not compatible with your joint fillers and your caulking and your silicones. All Sinak cures are compatible with adhesives, line striping, and joint compounds. So you always spray the joints. I recommend waiting to apply the cure until after saw cutting so that you can apply it to the surface, you can apply it to the joint walls, and then you apply it to the edges when you strip forms. Now, we have developed at Sinak a best practices policy of experience through different geographies around the country that have harsh environments. One of the things that we found on robotic industrial applications where we're doing places like Tesla or we're doing IKEA warehouses that have robot systems in them, have a very, very flat tolerance requirement. And one of the things that we found is at 48 to 72 hours after placement, you can come back and you can reapply to the joints. By then, the joints have cracked, they've opened up, and now not only have you addressed the top and the edges and the bottom and the first inch of saw cut, now you're actually going all the way down to the membrane and controlling the entire joint wall. That's going to reduce your curling or eliminate it completely. And in doing that, you have got a lot of less costs associated with doing grinding and leveling after the fact so that you can meet those high tolerances. So from a best practices standard, I always tell people to come back 2 days later. If you still have forms in place, you'll see a separation. Just squirt a little bit along the edge. And that one little simple task will save you days of nightmares of grinding edges.
All right. We will wrap up here with one more quick question. As a flooring manufacturer, what kind of bond warranty do I have using a product like VC5?
VC5 would warrant the adhesive bond to the concrete. We warrant that we are not a bond breaker. There is nothing that we have that will prevent adhesion. By working early in the process, we can guarantee that the finish of the concrete meets your textured profile. Remember, it's not necessarily that there was a product used. How smooth is the texture of the concrete that allows your adhesive to bond correctly? So our warranty says any commercial grade product will stick to us and will bond to us. We also warrant that you'll have no issues with moisture, moisture vapor, or alkalinity emanating up or through the concrete itself. So that's really key to understand. It makes the flooring contractor's life a little easier because, one, I don't know of a flooring manufacturer to date that offers a waterproof or a vapor moisture warranty for their products. There are some moisture tolerant adhesives, but again, their warranties are limited to an arbitrary RH number, whereas with Sinak, there are no limits on RH and there are no limits on calcium chloride numbers. You're fully protected. So from a flooring contractor perspective, I would embrace it because you have a complete release of liability. You only have to cover your workmanship and proper installation. That's it.
All right, I've got another one here that I said we were going to wrap it up, but I feel like this one's relatively important. VC5 SDS indicates 18% sodium silicate content. STM F710 requires concrete to be free of reactive silicate. How do you address?
This would probably be my favorite question in the world. As a member of the F6 committee, F710 is a practice. It is not a weighted test method or specification. It is designed as the minimum guidelines for a flooring contractor who has no prior knowledge of the concrete's condition or abilities to perform, so that he has a basis to work off of to ensure he's not held liable for his problem. I mentioned earlier about urethanes. There are multiple silicate chemistries in the market today, and they range broadly. A silicate densifier and a silicate curing agent are not the same thing. The silicates are processed differently, and silicon contamination has been removed from F710. So I would encourage you to get the most recent version. Not all silicates are the same, so we would have to specify which ones. Now, an unreacted silicate, such as a sodium silicate that requires calcium hydrate for a reaction, could potentially cause a problem. Sinak materials are unique in our processing in that all of our materials, both our sodium silicates and our lithium silicates, are pre-catalyzed. We require no reaction to take place with unhydrated cements, and because of that, we are totally inorganic and non-soluble. If I had no knowledge of a concrete slab, I would adhere to F710. If I have knowledge of what process was used, then I would encourage and require that the general or that Sinak provide me, the flooring installer, a copy of the Sinak warranty before I proceeded. And that is really a smart best practices for you, because Sinak's goal is to ensure that the property owner is covered, and that means all subcontractors involved are also covered. We don't want you guys to get into a finger pointing match later. We want you to be able to come in, do your job, and leave, and we want our owner to be satisfied with the result. So that communication and engagement early is essential.
All right, fantastic. If for some reason Jeff and I did not answer your question, Jeff and his team will definitely be receiving a copy of these all, and will be following up with you specifically or providing documents to those that had requested. So I would like to thank Jeff and the Sinak team for providing this great educational opportunity, and to thank all of you for joining today. In the next few weeks, you can expect your AIA credit to be submitted through Sinak and a certificate of attendance if you are a registered architect. You will, registered or not registered, if you attended, you will receive your certificate. So let's just go with that. Once you exit today's webinar, you will have a survey that will automatically pop up on the presentation. We would definitely love it if you would take a few short minutes to complete that. We would love to get 100% feedback, so thank you so much. You will receive a follow-up email this week with a link to view a recording of today's presentation. On behalf of Construction Supply Group, Whitecap, and Sinak, Thank you for joining us today. We appreciate your patience during our technical difficulty. Have a great rest of your day. Thank you.